Hello dear students, hope you are fine. In this lecture, today we will learn about data highway, computer input-output operations, programmed input-output operations, interrupt, vectored interrupt, priority interrupt using priority encoder, and priority interrupt using daisy chain. Data highway can be meant of a network of computer networks, other devices, and switching systems used for the transfer of digitized information. They connect programmable controllers, computers, and other devices so that they can communicate and exchange data with one another. A cable system is the physical means of transmitting this data between nodes. A data highway network uses peer-to-peer communication through a modified token passing scheme called floating master, which controls the access to the network and can initiate signals at any time. With this arrangement, nodes bid for temporary mastership based on their need to send information. A message from a node on one network to another node on other network uses message transmission time in both networks. To achieve the best performance, configure each network so that minimum of messages cross between them. We can do this by grouping stations that need to frequently communicate with each other on the same network. Input-output systems transfer information between computers' main memory and the outside world. An input-output system is composed of input-output devices, that is peripheral devices, input-output control units, registers, and software to carry out the input-output transactions through a sequence of I/O operations or input-output operations. The host sets command ready bit when a command is available for the controller to execute. Input-output devices can be classified as serial and parallel. Serial means they are able to transfer bit streams one bit at a time, and parallel devices have a wider data bus and can therefore transfer in parts of one or more bytes. Like any other activity in a computer system, input-output is a combined work of both hardware and software. A software which is executed to carry out an input-output transaction for a specific input-output device is called a device driver. An example of such an I/O transaction is reading a block of data from a disk to memory. The software to do this is simply a sequence of I/O operations or instructions to transfer data between the peripheral devices and main memory, and to enable the central processing unit to control the peripheral devices connected to it. The system is notified if a read or write operation by sending a special signal along with pass. Thus, I/O operations are of two classes: control operations and data transfer operations. Programmed input-output. Programmable input-output or program input-output is one of the input-output technique other than the input-driven I/O and direct memory access, that is DMA. The programmed I/O is the simplest type of I/O technique for the exchanges of data or any type of communication between the processor and the external devices. With the programmed I/O, data are exchanged between the processor and the I/O module. The processor executes a program that gives it direct control of the I/O operation, including sensing device status, sending a read or write command, and transferring the data. When the processor issues a command to the I/O module, it must wait until the I/O operation is complete. If the processor is faster than the I/O module, this is wasteful of processor time. The overall operation of the programmed I/O can be summarized as follows. First, the processor executes a program and encounters an instruction relating to an I/O operation. Then, the processor executes that instruction by issuing a command to the appropriate I/O module. In the third stage, the I/O module will perform the requested action based on the I/O command issued by the processor, that is read or write command, and then set the appropriate bits in the I/O status register. Lastly, the processor will periodically check the status of the I/O module until it finds that the operation is complete. An interrupt is a signal to the processor emitted by hardware or software indicating an event that needs immediate attention. Whenever an interrupt occurs, the controller completes the execution of the current instruction and starts the execution of an interrupt service routine, that is ISR or interrupt handler. Interrupt synchronizes the processor with the I/O device, in which the device sends the signal when it is ready. In another words, we can tell that the interrupt is a response by the processor to an event that needs attention from the software. An interrupt condition alerts the processor and sends control signal to the processor and serves as a request for the processor to interrupt the currently executing code when permitted, so that the event can be processed in a timely manner. If the request is accepted, the processor responds by suspending the current activities, saving its state, and executing a function called an interrupt handler, or it can be told as ISR, to deal with the event. This interruption is temporary, and unless the interrupt indicates a fatal error, the processor resumes normal activity after the interrupt handler finishes. Interrupt latency is the time between the receipt of an interrupt and its service. Interrupts are commonly used by hardware devices to indicate electronic or physical state changes that require attention. Interrupts are also commonly used to implement computer multitasking, especially in real-time computing. Systems that use interrupts in these ways are said to be interrupt-driven. In a computer, a vectored interrupt is an I/O interrupt that tells the part of the computer that handles I/O interrupts at the hardware level that a request for attention from an I/O device has been received, and also identifies the device that sent the request. A vectored interrupt is where the CPU actually knows the address of the ISR in advance. All it sends is that the interrupting device sends its unique vector via a data bus and through its I/O interface to the CPU. The CPU takes the vector, checks an interrupt table in the memory, and then carries out the correct ISR for the device. So, the vectored interrupt allows the CPU to be able to know what ISR to carry out in software or memory. Besides, a non-vectored interrupt is where the interrupting device never sends an interrupt vector. An interrupt is received by the CPU and it jumps the program counter to a fixed address in hardware. Priority interrupt is a system which decides the priority at which various devices which generates the interrupt signal at the same time will be served by the CPU. The system has authority to decide which conditions are allowed to interrupt the CPU while some other interrupt is being serviced. Generally, devices with high-speed transfer such as magnetic disks are given higher priority and slow devices such as keyboards are given lower priority. When two or more devices interrupt the computer simultaneously, the computer services the device with the higher priority first. A priority encoder is a circuit or algorithm that compresses multiple binary inputs into a smaller number of outputs. The output of a priority encoder is the binary representation of the original number starting from 0 of the most significant input bit. They are often used to control interrupt requests by acting on the highest priority interrupt input. If two or more inputs are given at the same time, the input having the highest priority will take precedence. The daisy chaining method involves connecting all the devices that can request an interrupt in a serial manner. This configuration is governed by the priority of the devices. The device with the highest priority is placed first, followed by the second highest priority device, and so on. This way of deciding the interrupt priority consists of serial connection of all devices which generates an interrupt signal. The device with the highest priority is placed at the first position, followed by lower priority devices, and the device which has the lowest priority among all is placed at the last in the chain. In daisy chaining system, all the devices are connected in a serial form. The interrupt line request is common to all devices. If any device has interrupt signal in low level state, then input line goes to the low level state and enables the interrupt input in the CPU. When there is no interrupt, the interrupt line stays in the high level state. The CPU responds to the interrupt by enabling the interrupt acknowledgement line. This signal is received by the device 1 at its P1 input. The acknowledgement signal passes to next device through P0 output only if device 1 is not requesting any interrupt. That's all for today. Thank you.